Welcome to equations of parallel and perpendicular lines. Please read my write-up because it discusses what these lines are and how to determine which lines are parallel, which lines are perpendicular, and which lines are neither parallel nor perpendicular. I did write down two symbols here as I'm writing questions in these sections. If I write two lines that go side by side like this, that means parallel lines. So that's the symbol for parallel lines, and perpendicular lines will look, the symbol for that will look like this. So let's go ahead and look at some examples. The first few problems will ask you the exact same question. Are two given lines parallel, perpendicular, or neither? Here is number one. Number one gives you two lines, specifically equations of those two lines. This is your line 1 and this is your line 2, and we need to state if these lines are parallel, perpendicular, or neither parallel nor perpendicular. To determine if the lines are parallel, perpendicular, or neither, you have to compare their slopes. However you're able to find that slope, you need to find it and compare it with the slope of the other line. And then once you're able to compare the slopes, you should be able to come to the conclusion. What you need to notice is each of these equations is in y equals mx plus b form simply because y is by itself. Y is by itself in the first equation, y is by itself in the second equation. If that is the case, the slope is actually on the surface. It's right there next to the x. Because remember, mx plus bm is the slope. Which means line 1 has the slope of 4, and line 2 has the slope of negative 1/4. Let's go back to the definitions of slopes of parallel lines and perpendicular lines. Parallel lines would have the identical slopes, which means for these two lines to be parallel, this line has 4, then this line would also have a 4, etc. They're clearly different. For the two lines to be perpendicular, our slopes must be first opposite in signs. One is positive and one is negative, and that condition is met here because our 4 is positive and our negative 1/4 is negative. And the second condition is they have to be reciprocals of each other. That means they have to be flipped. So if you take the first slope and flip it, meaning put the top of that fraction to the bottom and vice versa, if you get the second slope, that means the lines are perpendicular. Well, your first slope is 4. And some might ask, well, how do I flip it? Well, 4 can actually be written as 4/1. So once you flip it, you get 1/4, which is exactly what we have in the second line, combined with the condition that they're opposite in signs, our two lines are perpendicular. The exact same question for number 2 here. You're given two lines. You do not have their equations. What you have is that the first line goes through these 2 points. That's your line 1. And the second line goes through these 2 points. That's your line 2. You have to determine if they are parallel, perpendicular, or neither. Remember, to answer that question, you have to know their slopes. It's not equations here. We cannot pull the slope from the equation. We will be using the slope formula to find the slope of each line, and then we will compare them to make our conclusion. So for line 1, using this formula, we get m equals y2, which is negative 66, minus y1, which is 114. Going back to the second point, going to x2, so negative 8, minus x1, which is your 12. So on the top you have negative 180, and on the bottom you have negative 20. Once you divide negative 180 by negative 20, you get 9. Let's do the same for line 2. Now, before I calculate the slope for line 2, please keep something in mind. We do have the slope of this first line, and we got it to be 9. So for us to conclude that the two lines are parallel, the second slope would have to be the exact same slope. It would have to be 9 again. For us to conclude that the two lines are perpendicular, the second slope will have to be opposite in sign, so it would have to be negative, and flipped. So instead of 9, it would be 1 over 9. So negative 1 over 9. If neither one of those cases will hold, then it's neither not parallel, not perpendicular. So let's simplify. 30 minus 14, that's 16. And 10 minus 2 is 8. 16 over 8 is 2. So the first slope is 9, the second slope is 2. They're not parallel, they're not perpendicular. Here's question number 3. It's a little different. It says, find the slope of the given line and also give the slope of a line that is perpendicular to this line. Remember, to find the slope of the line, if you have an equation, which ours is an equation, it's not 2 points, it needs to be in y equals mx plus b form. Otherwise, what we have looks like standard form, and none of those numbers really help us to state the slope. So we have to rearrange this equation so that y is by itself. This y right here is by itself. And then whatever number ends up being next to x will be our slope. So the first step will be to take negative 9x and add it to the right side because it's negative on the left. Once you move it to the other side, it becomes positive. And then to remove the 2 away from the y, I will divide every term by that 2. So the number next to x, which is m, your slope, is positive 9 over 2, which is the slope of this line. So let's think about what would be the slope of the line that is perpendicular slope. Well, remember, perpendicular lines have slopes that are opposite in sign. This one is positive, so ours will be negative. And the reciprocal, so instead of 9 over 2, you flip it, it becomes 2 over 9, and that's your answer. So here is your question number 4. Write an equation. So it's asking us to produce an equation for a line, and that equation needs to be in slope-intercept form. So what they want from us at the end should look like this. If the line is parallel to this other line, so this isn't the equation of the line that we are writing for. This is the equation of some other line, but we know that our line will be parallel to it. And our line also passes through this point with coordinates 10, 4. Well, 2 useful pieces of information are given to us. We have a point, which is nice. That's our x1 and y1. So that's good to use in y minus y1 equals mx minus x1 form. So our x1 here will be a 10, and our y1 here will be a 4. The slope, now we need this m. And that's where the equation of this other line comes handy, because the line that we're writing for, which is this line here, is parallel to this line. Parallel lines have the same slopes. Ask yourself, what is the slope of the line y equals 5x minus 3? Well, because it's in slope-intercept form, the slope is 5. So that 5 will be placed here. If this question said perpendicular instead of 5, you would be placing negative 1 over 5 where you see m. But ours are parallel, so we just use the 5 as is. So we get y minus 4 equals 5x minus 10. Then I'm going to distribute the 5. And then I'm going to add the 4. So the final answer is y equals 5x minus 46. That's it. Now here's the final question for this recording. Write an equation for a line that is perpendicular to the line with equation y equals 9 and passes through the point negative 6, 7. So the point is nice. That is our x1 and y1. So y1. So that's great. Now, what kind of line is y equals 9? Well, y equals 9, if you recall, is a line that passes through 9 on y-axis, and it's horizontal, it's parallel to the x-axis. So what kind of line would be perpendicular to a horizontal line? Well, that line will have to be vertical to be perpendicular to horizontal. A vertical line that passes through the point negative 6, 7 is right here in black. So this is your point, negative 6, 7, and that's the vertical line that goes through that point. How would you write an equation of a vertical line that hits your x-axis at negative 6? You write x equals negative 6, and that's your final answer.